This video is about the quadratic formula and the discriminant. Quadratic formula can be used to solve any quadratic equation, and there is the formula. So x equals negative b plus or minus the square root of b squared minus 4ac, and then that whole numerator over 2a. It comes from completing the square, so if you've learned that method, the formula is derived from that. And it's a way of solving for both of the solutions for x without having to factor or use square roots. You can just plug a, b, and c into the formula. So the first thing you want to do is make sure that your equation is written in standard form and says equals 0, so that you can see what a, b, and c are. So we want to start by subtracting the 4 from both sides so that it says equals 0. And now our equation is in standard form. When it's in standard form, a is the coefficient of x squared, so here that's 1. B is the coefficient of x, so here that's 5. And c is the constant term, which here is negative 4. We're going to plug those into the quadratic formula and solve for the two solutions for x. So x equals negative b, which is 5, so we write negative 5, plus or minus the square root of b squared. This time the b is not made negative, but we're going to square it anyway, so it wouldn't matter. Minus 4 times a times c. And that whole thing is over 2a. Make sure that your fraction bar goes all the way back in front of the negative 5. Simplify what's underneath the square root sign first. So 5 squared is 25. Minus 4 times 1 times a negative 4 is like saying minus a negative 16. So we'll say plus 16. And we can simplify the denominator as well, 2 times 1. Continue simplifying what's underneath that square root. (25 plus 16). And then we're looking to see if we can simplify that square root. Because it's a square root of 41, we're looking for a perfect square that goes into 41, and there aren't any. And that means that the answer is actually as simple as it's going to get. So when you get a non-perfect square and you can't simplify it at all, it's an irrational number. We're going to leave our final answer written like this. It is two answers. It's negative 5 plus or minus the square root of 41 divided by 2. And those are the solutions to this quadratic equation. In some cases, some special cases, there may only be one solution. So that was 2 solutions, and this is a case where there's only one. Start the process out the same way. Get it to say equals 0. So we're going to subtract 4 from this 13. We're going to use the quadratic formula. Even if you see that there's another method possible, we're practicing here how to use the quadratic formula. So that's what we'll do. X equals negative b. And since the 12 is already negative, we make it positive. Plus or minus the square root of b squared. Notice I'm putting it in parentheses so that I remember it's going to become positive. Minus 4 times a times c, all over 2 times a. Simplifying what's under the square root, we have negative 12 squared, which is 144, minus 16 times 9, which is 144 as well. And 144 minus 144 is 0. And then simplify the denominator, 2 times 4 is 8. Well, the square root of 0 is 0, because 0 times 0 gives you 0. And so 12, whether you add 0 to it or subtract 0 from it, so 12 plus or minus 0 still just gives you 12 over 8. And so because the plus and minus dropped out since it was with the 0, there really only is one solution to this equation. And we can simplify it. Whoops. We take 4 out of both of these, so we simplify it. And there's the one solution. Now you could have obtained that by factoring. You would have seen that it was the same factor twice, a perfect square trinomial, and that's how you end up with only one solution. In some cases, there are 2 imaginary solutions. So we start the same way. Add the 10 so it says equals 0. Use the quadratic formula. Negative b plus or minus the square root of b squared. Make sure you put that b in parentheses because you're squaring it. Minus 4ac over 2a. Simplify what's under the square root. 36 minus 40. Remember, when you get a negative underneath the square root sign, there are no real solutions. So if you've learned imaginary numbers, you're going to continue and simplify with I. So the square root of negative 4 is I going to come out, and the square root of 4 is 2, so 2 is going to come out as well. So 6 plus or minus 2I over 2. And if you can simplify all three of these numbers, then you should simplify the fraction. So I'm going to divide them all by 2 and simplify the fraction to 3 plus or minus I over 1. And I don't just show that 1. So 3 plus 4 minus I. So the discriminant, which is just the part underneath the square root sign, tells you if there are going to be 2 real solutions, 1 real solution, or 2 imaginary solutions. So we just went through examples that showed all of them. These 3 examples here, we're not going to solve them. We're just going to predict whether there are 2 real, 1 real, or 2 imaginary solutions. All we need to do is evaluate the part that comes underneath the square root sign. If you go back and look, when there were imaginary solutions, the part under the square root sign was a negative number. That's because the square root of a negative gives us an imaginary. When there was 1 solution, the thing underneath the square root sign was 0, neither positive nor negative. And go back one more, when there were 2 solutions, like in this case, the value underneath the square root sign was a positive number. So we're looking for positive versus 0 versus negative, and that'll tell us how many solutions we're going to get. So just figuring out the discriminant here, we're going to do b squared minus 4ac and see whether it comes out positive or negative. For us to fill in a and c. Fill in a is 1, c is 17. So we're going to simplify this. 8 squared is 64. 4 times, what's this? 4 times 17 is 68. So we're subtracting 64 minus 68. We get a negative 4. Remember, when there's a negative underneath your square root sign, you will get 2 imaginary solutions, because the square root of a negative gives you imaginary number. Evaluate the discriminant here. B squared minus 4 times A times C. It equals 64 minus 4 times 16, which is 64. This equals 0. When you get a 0 underneath the square root sign, the plus or minus is going to go away with it, so there's only 1 real solution. And you can predict what this one will be. And you have b squared minus 4ac. This gives us a 64 minus 4 times 15, which is 60. It's positive 4. And when we get a positive underneath the square root sign, there are 2 real solutions. This is kind of more of an advanced algebraic topic, but now it wants us to use the discriminant to determine the values of c, for which this equation has 2 real, 1 real, and 2 imaginary solutions. This is actually a 3-part problem. It wants us to figure out what value for c would give us 2 real, what value for c would give us 1 real, what value for c would give us 2 imaginary solutions. So for 2 real, remember that b squared minus 4ac, which is the part underneath the square root sign, must come out to be greater than 0. Not greater than or equal to, but greater than 0, because that would mean it's positive. That's how we get 2 real solutions. I'm given b in this equation is 10, and I'm given that the a is negative 4. All I'm not given is c, so I can fill in the variable c to this inequality and solve for the c values that are going to give me a positive discriminant, and thus 2 real solutions. So 100, negative times negative is positive 16c. Subtract the 100 and divide by 16 to figure out that all c values greater than, let's reduce this to, let's see, negative 25 over 4. All c values greater than negative 25 over 4 are going to give us 2 real solutions. So what will give us 1 real solution? Well, we're going to get 1 real solution when the discriminant is equal to 0. When it's equal to 0, and you take the square root of 0, the plus minus goes away and you get 1 answer. Everything's going to fill in the same way. We have our b, we have our a, we don't have c, and it equals 0. I'm not going to show all the algebra again. It works out being the same. And so this time, when c is equal to negative 25 over 4, that's when we obtain 1 real solution. And then for 2 imaginary, we can switch, make this less than 0, and solve with the same numbers. If we plug in the same numbers and solve the same way, we're going to see that c has to be less than negative 25 over 4 in order to give us two imaginary solutions. And that is all.